Let's jump to our next topic, RAM. RAM stands for random access memory. It's a type of volatile memory used by a system to store data that is being actively used or processed. Unlike your hard drive or SSD, which stores data permanently, RAM is temporary storage that can be accessed quickly by the CPU. Data is available inside the RAM till the system is powered on. When you turn off your system, the data in RAM is lost. Let's see the importance of RAM. As we saw earlier, the CPU works at very high speed. To maintain performance, the CPU requires data in instruction to be executed at these high speeds. Fetching data from RAM is much faster, ensuring that the CPU can operate efficiently without significant delays. If the CPU were to fetch data directly from the hard disk, the latency would drastically slow down processing, leading to poor performance and if inefficiency. The CPU speed is very high, but the disk speed is relatively lower. To optimize performance, we need RAM that matches the speed of the CPU. So, how does RAM work? The data is stored in the storage as a program. All operations are controlled and managed by the operating system as previously saw. When you execute a program such as a Word document, the data and instruction need to run that program are loaded from your hard drive into RAM where it become a process. RAM allows the CPU to access data much faster than from a slower storage drive, acting as a high speed mediator. Once processes are complete, data is saved permanently on storage. Multiple programs run simultaneously as processes inside RAM. Once the process is complete, the data is saved permanently on storage. Now that we have an understanding of RAM and its use, let's look at different type of RAM. In dynamic RAM, data is stored in capacitors and needs to be refreshed regularly because capacitors have leakage issue which can cause the stored information to be lost. It is asynchronous, meaning it does not operate in sync with the CPU clock pulse. When the CPU requires data, DRAM may not be able to provide that information immediately, making it slower. Next is SRAM, which stands for static RAM. It is based on flip-flop circuits where data is stored. SRAM retain its data as long as it is powered on, so it does not need to be refreshed like DRAM. Data is written once and remain until the power is turned off. Storing and reading data is fast, but it requires more power. An example of SRAM usage is cache. The next type is SDRAM, which stands for synchronous DRAM. It is synchronized with the clock of the CPU, allowing it to provide data to the CPU at a higher performance data rate when needed. DDR SDRAM is also synchronous SDRAM but with double data rate. Nowadays, when we refer to RAM as DDR4 or DDR5, the double data rate refers to transmitting data on both edges of the clock signal. A single data rate system transmits read and write data only on the upward edge of the clock signal, but what double data rate does is it also uses the downward edge of the clock signal. In this case, the clock signal is used twice on both the upward and downward edges. The size of a single DDR module can be 32 GB, 64 GB, or 128 GB. The quantity of module to be installed in a single system depends on the hardware manufacturer. The image shows an example of a system's task manager displaying all running processes on the left. The operating system allocates CPU time and memory to these processes, balancing the load to ensure no single process monopolizes the CPU. It prioritizes tasks based on importance and current needs. Memory or RAM is used for quick data access by the CPU. Each process is allocated a specific amount of memory with the OS monitoring usage to prevent any process from using too much memory. This management helps maintain system performance, ensuring programs have enough resources to function correctly without crashing or slowing down.